All right, let's try a question on equilibrium from the spring 2015 midterm 2. So as with all these videos, I'm going to walk through the solution, pointing out how I pull out the information from the problem, how I parse that information, and any shortcuts or decisions I make along the way as I solve the problem. So let's get going here. All right, so we have demand for cab rides in Williamsburg is given by the following inverse demand function. P of R is equal to 10 minus 1 over 10 R, where R is the number of cab rides demanded at a price of PD. The inverse supply function for cab companies is PS of R is 1 over 10 R, where R is the number of cab rides companies are willing to provide at a price of PS. Okay, so pretty standard demand and supply functions here. So let's go ahead and start with part A then. What is the equilibrium price and quantity of cab rides in Williamsburg? So to get the equilibrium here, since we're given both the inverse demand and inverse supply, we can just set those equal to each other. So I'm going to set PD of R equal to PS of R. And when we solve this, it's going to spit out a value of R that's going to be our equilibrium quantity of cab rides. So let's go ahead and do that. So PD was 10 minus 1 over 10 R. PS was 1 over 10 R. All right, so I'm just going to move my minus 1 over 10 R to the other side. So it's going to give me 10 is equal to 2 over 10 R, which is the same as 1 over 5 R. Now if I just multiply through by 5, I've got that R is equal to 50. So that's my equilibrium quantity of cab rides. To get my equilibrium price, I just need to plug that number back into either one of these functions, right? If I look at them, the simpler one to me is the supply function, so I'll go ahead and do that. So price is going to be PS at 50. It's going to be 1 over 10 times 50, which is just equal to 5. Right? And notice that if we'd plugged it into the demand function, we would have gotten the same price. So if I had some spare time and I wanted to check my answer, I might go ahead and do that. Okay. So let's move on to part B now. Suppose that the city of Williamsburg decides to raise government revenue by putting a quantity tax on cab rides. They decide that for every ride a cab company provides, it must pay $2 to the city in taxes. What will the new equilibrium price charged to consumers and quantity of cab rides be? All right, so we have a quantity tax, so that's going to add $2 to the price. So when I'm thinking about setting the price consumers pay equal to the price sellers receive, right? The price consumers pay is going to be $2 higher. So I'm basically setting up the same equation to find equilibrium, but I'm including that $2 wedge in price between the two, right? So what consumers are paying at the equilibrium quantity has to be what suppliers are willing to accept the equilibrium quantity plus 2, right? Because that $2 is going to go off as tax revenue. So let's go ahead and plug all of that in now. So we still have our 10 minus 1 over 10 R on this side. We still have our 1 over 10 R for supply, but we now have this plus 2. So all that's going to change is that now on the left-hand side, I'm going to get 8 when I subtract that 2. That is now what's equal to 1 over 5 times R, when I move that minus 1 over 10 to the right. So when I multiply through by 5 here, I'm going to get 40 is equal to R. That is my new quantity of cab rides, right? Now, here's where I have to be a little bit careful. The question wanted to know what's the new equilibrium price charged to consumers, right? And so if I plugged 40 back into the inverse supply function, that's the price that sellers get net of the taxes. That's not what the question is asking for. They're asking for what are consumers paying. So in this case, I have to plug it into PD here. If I plugged it into PS, I'd have to add the $2 in. Not a big deal. But let's go ahead and find that. So PD at a quantity of 40, right? That's going to be 10 minus 1 over 10 times 40. So that's 10 minus 4. That's going to be 6. So if consumers are paying 6, that means sellers are keeping $4 once they pay that $2 tax. Right? All right, so let's move on to part C and a little new piece of paper here. So how much government revenue will the city of Williamsburg generate as a result of this new tax? Well, this one we've pretty much done all the hard work for, right? Our tax revenue is just going to be equal to the size of the tax times the number of rides that are taken, right? And so that is going to be the $2 tax times the 40 rides. So we're going to raise $80 in tax revenue, right? Okay. Time to move on to part D. How much deadweight loss does the tax generate? Oh. All right, here, before I answer, I want to do a quick sketch for myself to think about what this deadweight loss should look like. So if I go back to my supply and demand functions, right, my supply function is price as a function of R is equal to 1 over 10 times R. So when R is 0, price is 0. And then it's going to be a straight line coming up. As for demand, when R is 0, price is going to be 10. So that thing's going to start at 10, and it's going to come down like that, right? So we already solved for this equilibrium here, which was at a price of 5 and a quantity of 50. If we look back to our part A answer. And then in our part B answer, we realize that now with the tax, consumers are up here at $6, producers are down here at $4, and all that is taking place at a quantity of 40. So my deadweight loss is this triangle here, and now I have all the numbers I need to solve for that, right? My deadweight loss is going to be 1/2 the width of that, which is going to be 50 minus 40, times the height of that triangle, which is just the size of the tax. That's 6 minus 2, or 6 minus 4, being the size of the tax 2. So now my deadweight loss is simply 1/2 times 10 times 2. So 1/2 times 20 is just going to be 10. All right, so not too bad, but a whole lot easier after I drew the graph myself to know what I was looking for. All right, now we've got one last part here. Suppose that the residents of Williamsburg say that it is unfair to tax cab rides that are essential, like trips to the hospital. The city agrees to only impose the tax on non-essential cab rides, but adjust the size of the tax so that the same amount of tax revenue is generated. Will this change in policy lead to more or less deadweight loss than the original tax? Be certain to explain your reasoning. Okay. Well, the big difference here is that non-essential rides will have more elastic demand than essential rides, right? If the price goes up and I don't really need to take the ride, I might not take it anymore. If the price goes up but I need to get to the emergency room, I'm still going to take it. So given that non-essential rides will have more elastic demand than essential rides, just finish that thought, right? Quantity for non-essential rides will drop by more than it would for essential rides when the tax is imposed. All right. So that smaller quantity will require a bigger tax per unit to generate the $80. All right. So now let's go back up to our graph here and realize that we're increasing the height of that triangle because we need to use a higher tax, and we're increasing the width of that triangle because of the bigger drop in quantity, right? So both the width and height of the deadweight loss triangle increase, meaning more deadweight loss. All right, so there's our complete reasoning for part E, and that is the last thing that we were asked to do in this question.